Alright, so we're going to have a look at the inner workings of a Lagoa system, a basic system, and start to dissect it and understand what exactly makes it up. Okay, so this compound is great and all because it pretty much simplifies things, but what we want to do is unsimplify things for the purpose of this training product. So here's what I'm going to do. I'm going to take the pouring liquid point cloud, I'm going to delete it, get it out of my scene. I'm going to bring back the cuckoo puffs. If it tries to resimulate, I'm just going to cancel it, go back to the first frame. If I hit play, this should look familiar. This is what we had before. Okay. One thing that I really like to do is turn on the frame rate inside of my viewport. So I hit Shift S to open up my camera visibility settings, and I'm going to go to my stats and turn on frame rate. That way I can see my FPS down there or my frame rate. So when I hit play, get a good idea of my frame rate here. I'm getting about 15 frames a second here. What makes a Lagoa ice tree tick? Well, select the cuckoo puffs, hit refresh, and let's have a look at this. Okay, so here's what it's all made up of. You got your ice tree node and your simulation root over here, but this stuff is the main chunk of what makes everything work. So let's start off at the top. First thing is Lagoa Emit grid node. This node is what emits particles from the null in our scene. Okay, so if I look at this null right now is emitting particles thanks to this emit grid node, and if I go to the PPG over here, you can see that there's some really important settings here. Things like the amount of resolution, the shape and display of the particles. So for example, down here I've got sphere, but I can change that and stuff. I'll talk about that later, so don't worry about that now. All you need to know right now is that this node here, this emit grid node, basically emits the particles from your null. Okay, and this null over here is just a null, so it's just get data that grabs the null and plugs it into the emitter. Then down here, next thing we have is Lagoa Forces. Okay, so each Lagoa system has one of these add forces nodes or compounds by default. If I open it up, you can see it's got some default stuff here for quite a few different things, and it's all forces, so things like gravity, wind, stuff like that. And we'll get into that later. Then we've got other things over here. So we've got the main material and the Lagoa phase. These are pretty important, and Lagoa wouldn't be able to work without these. The material works a little bit differently than what you might associate the word material with inside of Softimage. In Softimage, when you talk about materials, usually you're talking about the material manager and shaders and materials in your scene. When it's Lagoa, Lagoa doesn't refer to materials as shaders. A material is actually a substance. Okay, so let me open up this PPG to show you some stuff here. We've got pressure settings, viscosity settings, elasticity settings, different things like that. Okay, so when we're talking about Lagoa materials, we're not talking about shaders. We're talking about a substance, like for example, the properties of water, or the properties of honey, or the properties of dirt. Okay, that's the type of material we're talking about. We're not talking about shaders, so very important not to get that confused. And there's a lot of materials that come with Lagoa. You can customize the main material, which is the default material. It's pretty much an open material that you can go and customize. So this material could end up simulating water, it could end up simulating honey, it could end up simulating dirt, it could end up simulating jello. It could pretty much simulate whatever you want it to. You just have to know how to use the different parameters that you see here, and there are quite a few parameters. I'm going to show you how to simplify things in a bit. Then we've got the Lagoa phase node. The Lagoa phase node controls the phase of the current particle emission. Now we're going to really talk about phases a lot later, and I mean a lot later in this training product, so we're not going to worry about it now. What you should know about it right now is that you need at least one Lagoa phase in order for your Lagoa effect to work. If I look at this entire tree, you notice that I have this emit grid up here. This emit grid right now is working with this Lagoa phase. Okay, and it's very important that it has it and that it's set up correctly. By default, it's set up correctly. Okay, if I look at the properties over here, it doesn't have many properties. It's got a phase ID and some other stuff. but we'll talk about that later. Don't worry about the Lagoa phase, just leave it alone. It does its job without you having to do anything to it or configure it, anything like that. Then down here we finally have the Lagoa Assimilate Multiphysics node. This is the one where all the kind of magic happens. Okay, if we look at this one, it's got a lot of properties. We got a lot of stuff that basically controls the solver and the way that this thing gets calculated. You've also got some debugging stuff down here, which we'll look at later. We've got some optimization stuff down here, which is very important, and I'll talk about this later on, but you'll see how this has a very, very strong impact on speed and performance. Okay, so we'll be talking about some other stuff in here in a bit. Okay, so that's pretty much it. That's the whole ice tree right there, and this is the stuff that makes the Lagoa simulation tick. Alright, I'm going to end this video here, and in the next video I'm going to start to look at all of these nodes one by one, and we're going to start to play around with this and see how changing the different parameters change the look and behavior of our Lagoa simulation.